enumerations are variables that really contain two things. One is its name, which you can access via the toString method, and two is its value, which we defined it as for blue was a 234. Okay. So now let's see what happens when we do message box show, and we do a toString on the enumeration variable itself. We actually got its name, blue. Very interesting. Now what about its value? Well, its value is a little bit trickier. We do this. Okay. See what I'm not sure if you understand what I've done, but I'm going to explain it. Now normally C was declared as type my color, right? But if I precede wherever I use that variable, if I precede it by a different type name in parentheses, that converts or casts that variable into the new type. So the enumeration contains the value 253 or whatever it was, and I now take that out of the enum and convert it to an integer, and then I call the toString function on that. So now instead of blue, I should get whatever value corresponds to blue, which is 234. So let's try it. Sure enough, 234. Okay, I've confused you enough with enums. Let me just quickly cover some of the other variable types. I will not do examples because we don't use these as often. Another popular variable type is called a double, and these are floating point numbers, basically, like 47.3 or 3.1415. These are numbers that cannot be represented as integers, right? They're not whole numbers, they're fractional numbers, and they're represented using decimal points. And we can use these to represent an even wider range of numbers than we can with integers, like beyond 2.3 billion. We can represent, trillions and quadrillions and all that kind of stuff, numbers too large for us to even imagine. And with doubles, they can be represented with up to 16 digits of precision, which is very nice. And these are stored in memory using 64 bits or 8 bytes. And this is the preferred data type for all floating point math. So if you've got a program where you want to do computations using dollars and cents, it's not a bad idea to use doubles. Or temperatures that have greater precision than just the nearest degree. Again, you would be using doubles. And we will be using these at least a little bit, especially if we expect the variable value to exceed the supported range for an integer. Another data type is an unsigned integer, or a uint. And these are basically non-negative integers. So 0, and they range from, for a uint 32, they range from 0 to about 4.7 billion. Now, because you're not splitting up the range over the positive and negative, you're actually getting twice the maximum value a uint has twice the maximum value that an integer does. Remember, an integer goes from roughly minus 2.3 billion to plus 2.3 billion. Well, an unsigned integer basically shifts that range to the right by about 2.3 billion, giving you values from 0 to 4.7 billion. So it takes up the same amount of space as an integer, 32 bits or 4 bytes. And when would you use this? If you need an integer that has a higher positive maximum value than a regular integer, so something beyond 2.3 billion, and that doesn't have any negative values, can never be negative, or you're using what's called bitmap fields, and I might talk about those much later on. But unsigned integers are used a lot. We probably will not be using them much in this class. Next is the little brother of the double, which is a float or a single. This also represents floating point numbers with decimal points, but it has a lower range than double, and whereas a double can represent up to 16 digits of precision, a float can only have about 7 digits of precision. And historically, floats actually take up half the space as a double, 32 bits instead of 64 or 4 bytes. And historically, computations with floats used to be a lot faster than computations with doubles. But now Windows is supported on 64-bit processors, and even 32-bit processors have 64-bit math coprocessors, so really there's not much of a difference in computation time between the two data types. So if you need floating point numbers, use doubles, don't use floats. The last couple types, one of them, second to last, is decimal. And these are also floating point numbers, and I don't use these much, but they have a smaller range than floats and doubles, but they have up to 29 digits of precision. They use up 128 bits, twice as much as a double. And they're used primarily by the numeric up-down control, which we will talk about soon. Beyond that, I don't use decimal types. And the last type that I'm going to talk about is a char, a character. And these are single ASCII characters, which are internally represented by an integer. There's a table called the ASCII table, which shows you what integer code each character has. And I didn't say this in the notes, but ASCII characters are delimited by single quotes. So whereas strings are surrounded by double quotes, characters are surrounded by single quotes. And these are letters, numbers, white space, and some non-printable characters. They're represented usually in 16 bits or 2 bytes. And we're not going to use them much in our code, except if we try some of the fancier string functions which require the use of characters. And that concludes covering data types. I know it's a lot of information, and we're going to get into some more details for some of the data types, particularly strings and integers. But I want to give you an overview of what kinds of data types are out there. And I guess I'll see you next time.